Loud enough. Okay, so we're going to graph that. Now, we have different kinds of functions in math. We have algebraic ones, we have polynomials, we have trig, we have exponentials, we have logs. I know all the difference between all those, but you guys aren't as good at that. So you're going to have some problems with the limits in terms of knowing what to do when. And the trig ones, for the moment, we are going to use our graphing calculator. Now, if you have nice polynomials, that means the exponent is a whole number. No fractions, no negatives. They'll behave nicely. But this is a trig one. It doesn't behave so nicely. We also have one called a step function, a greatest integer function, which we're going to look at today. So we're going to graph this one, and I'll show you some things about graphing that. And I'm going to go to y equals, and I'm going to clear that out. When they did the new operating system, they didn't fix this problem. I'll talk about that in a second. Okay, so we're going to graph this, and I want the sine of x divided by x. Now, the 83s will not put the parentheses in. So if you don't put the parentheses in, you're going to have a problem. Also, the other calc teachers today were saying that you can't see the holes on the 83. I thought you could, but I'm not sure. Okay, and we're going to do divided by x. And we're going to zoom. If you didn't know about this, there's a trig button. I always zoom at trig. Pardon? Oh, this is continuing on yesterday's sheet, which was yellow. We're going to finish it up. We're not going to do the greatest integer on this. We'll do that on the next one. Okay, so you see zoom trig right there? So 7. I just said 7. So I can probably guess pretty well what this sine of x divided by x is getting close to when x gets close to 0. I'll pull that off. And what should I have done first that I forgot to do? What's the first thing we always do? Always substitute. Always substitute. I forgot to do that. I tend to forget to do that. So we have to figure out what the sine of 0 is divided by 0. And a lot of you will use your circle trig, but you're going to find out it's just, you can watch how fast this is going to take me to find the sine of 0. What's the sine of 0? 0. It's easy if you do it this way. So this is 0 over 0. And when you get 0 over 0, that means we have to do some work. In this case, I cannot do this limit algebraically. And actually, if I want to do this limit and prove that what it is, and we'll look at what it is, I have to use geometry. And it's not an easy proof. But what does it appear to be? Looks like the y value is getting close to 1. And I can say this, what this is like is if you're traveling on this road, which is the graph, what is that getting close to? I mean, you can't go on another path. You have to go on this path. And it looks like it's 1. So let me turn my axes off. Have you guys ever done that? Let's see. It's second format. I can't see that. I just memorized it now. And up in here, we're going to turn our axes off. And did everybody get a nice graph, by the way, now that I think about it? Oh, I know what the problem is. Okay, can you see that up here? Oh, yeah. We see just a tiny little hole. Just a tiny little hole. Okay, I know what the problem is, though. And this is always true for this class on the day of the AP exam. Mrs. Herson, Mr. Dahman, and I will try to do our best to get around to all the classrooms wherever you're taking the exam and remind you to press mode and make sure you're in radian mode. Bet you were in degree. I am in degree. But yours came out okay. Yeah. No, I'm in degree. Yeah. Are you in degree mode? You have to be in radian. No. Oh, let me see what you did. Yeah, it does. Okay, you want to zoom 7, because that'll put your trig in there in the right. I went second format. This is the blue one up there. Yeah, and then you can turn your axes off. And some of your games turn them off, so you kind of want to know where that is.
Mine's different, so
Oh yeah, yours is.
all the buttons are in the wrong spot.
But you still can zoom trig.
Yeah, I did zoom trig. It's on that right now. I just don't know how to turn the axes on.
I don't either.
Okay.
Okay. Axes off. And your games do that too. Okay, where are your name tags? I need to start learning names. I haven't made any effort. Okay. But you know what? Now I want my axes back on. So just make sure they're back on. So second, format, and then press enter. And then I do a second quit. We quit and go home. Okay, that's kind of cool. No? Oh, I forgot to look at the table. Actually, I have a table right here. But you guys might want to go into second table set, and we'll start at 0 and make that really small number, and then go second table. Now, this is not proof, but what do you think the limit is? Haley? What do you think the limit is? Looks like it's getting close to what number? 1. So it's safe to say, probably safe to say, that this is equal to 1. Now I'm going to use my creative pen, and actually you guys should have a special notebook where you put in, oh, I don't like that one. That's okay. Oh, I'll do the one I made up. That's pictures of my dogs, but you can't see them. It's kind of cool. We can make up our own creative pens now. So if there's something you want to make for a creative pen, we can do that. But this is really, really important. We have to know what this one means. It's just going to be automatic. You're going to say, I see that limit. I'm going to say it's 1, and it's done. You're not going to prove it or anything. Is that okay? So I would have a notebook with a special place in it of all the things you absolutely have to know. That's one of them. I know, I'll probably say something every day. No, I try not to, but that's one that you just have to know. Are you ready to go to the next problem? Okay. We're going to graph this one. We're going to use our calculator. We're going to look at our table. And then we're going to use the substitution. Because remember, I said the trig ones mostly you just want to do, you should always do substitution. But you're going to look at your graphing calculator. And the problem with this is the calculator doesn't really lie, but it just deceives you. So let's graph it. And what do I mean by it deceives you? So we're going to type in x squared minus, and then I want the cosine of x. Make sure you're still in radian mode. And we're going to divide by 10,000. And our window's fine. Our Zoom trig window's fine. So let's just press graph. What do you think the limit is as x gets close to 0? It doesn't say that. I should have said that. Looks like it's 0, doesn't it? Now let's look at the table. If I have my table already set from the last one, what do you mean a number? It says, what is this number? Do you know how to read that? It's negative 1 times, and this exponential is saying it's 10 to some power. It's 10 to the negative 4th power. And you remember your negative exponents? What is that? It's negative 1 over what? How many zeros? 4. You should be doing this in science, right? You don't use exponential notation in science? Scientific notation? Yes. I bet you do. Okay, so let's do the limit algebraically. So we're going to substitute in 0, and we get 0 squared minus the cosine of 0 over 10,000. And I know a lot of you want to say that the cosine of 0 is 0. Let's quickly use my little method of finding what the cosine of 0 is. And you know what the cosine curve looks like, I'm sure. What's the cosine of 0? 1. So it's going to be negative 1 over 10,000. That's what the calculator told us. It's just deceiving when you look at the picture. Plus, sometimes when you look at this table here, 10 to the negative 4th, they really want that. So the only way you're going to be able to verify what the answer is to substitute first. So beware of the calculator sometimes lying to you. Can you see that okay? Because I'm missing that one. So I'll just add a page. Okay, so we're going to jump. We're going to skip the greatest integer function, and we're going to go to example 6, because that's kind of a funny one. So it's the limit. I won't. It's the sine of 1 over x as x goes to 0. What happens when x gets closer and closer to 0? What does 1 over x do? You're getting 1 over 0. It's getting bigger and bigger, right? So the sine of a number that's getting bigger and bigger, what does the sine function look like? So as x gets bigger and bigger, does it look like it's going into a particular number? Sorry, my picture's getting lousy. Well, let's graph it. And I'm going to clear, and I'm going to do the sine of 1 over x. And I'm going to zoom trig, just make sure I'm in trig as I was. Remember, when you're looking for a limit, you're looking for a number, a single number. So you know what I'm going to do? I'm going to zoom in on this. So I'm going to select 2. Oh, I can't do that. And now it's right at the origin here, so I'll press enter. Okay, give me a number. Because if you think about what's happening with the sine function, it keeps going between 1 and negative 1. As x gets bigger and bigger, is it going to a particular value? Is it? If I try to trace it, I mean, look at here. It's negative, negative, error, positive, negative. It's picking up all these sine values. Let's do it one more time. Remember, limits don't have to exist. I don't know if I could say it's 0. What's the sine of a million? It's going to be a number somewhere between 1 and negative 1. So we say the limit does not exist. Now, how do I write does not exist? It does, doesn't it? Does not exist. Mathematicians are lazy. We don't like to write that out every time, so we say DNE. And why doesn't this exist? Because there are too many wiggles. Honestly, that's written in your book. Too many wiggles. It's true. Okay. Are you ready to summarize this? And then I'm going to quick quiz you. Oh, by the way, does everybody have internet? Okay. So I'll probably be doing some things with Schoology and Skyward in terms of little assessments, because they're kind of nice if I can find the time to write them. No, it doesn't exist. It's not undefined. Undefined means positive or negative infinity. Right now, I'd accept that. Yeah. Okay, so we're going to skip this one, the greatest integer function, for the moment. We're coming back to it. And then you should be able to do the summary. At the bottom of the page, there is a summary, which is blank. Mine's already written up. Okay? Yes. What are the 4 things that you should get? You should get a number. We're going to call it L. Might be hard for you to see, especially in the back. You could get 0 divided by a number. What's 0 divided by any number other than 0, at least? It's 0. You could get a number divided by 0. We did those last year. Those are vertical asymptotes. Those are undefined. Or you get 0 over 0, which is work. And I didn't have a chance to find that video, but I will. Or don't stop. Don't stop believing. Right? Don't stop. You have to do some work. You're either going to have to use your graphing calculator or do it algebraically. We want you to be able to do these algebraically if it's possible. Sometimes you're going to say it's not possible, and then I'll show you that it is. And then this is the big one right here. You have to know this limit. And remember that when you get 0 over 0, remember what that's called? It's on there. Oh, purple too. It's said to be indeterminate. Okay? Any questions? Okay, Cullen, you got that? You should. You just don't know what it is. Okay, so now what I'm going to do is you're going to get out your pink handout. That's the next one. Mine's not pink. And it looks like that. Oh. I love it. They changed everything on here and I can't find anything. Okay, so this is the pink one. You do it in the middle green system. Should check first too. Okay, what's the first thing you're going to do when you are looking for a limit substitute? Now, the other math teachers are a little more creative than I am. I just put a box over here. Can you write down the 4 things that will happen now? We just reviewed them. Can you do it? Because the limit is just a number. It's a single number, if you can find it. And what do you have to do with that one? Check with your neighbor. Yeah, we're going to do these. There's a typo. Okay, you should be able to do this because that's what we're doing. And you just have a worksheet for the weekend. You can find a half hour to work on your worksheet. I know it's going to be tough, but you can do it. Okay. When I get this number divided by 0, that's a vertical asymptote. You did this last year. You may not remember it, but you did. And when you had 0 over 0, that's a hole. And that's the one where you have to do work. Because I just want to find out what the function's getting close to when I'm near that place that gives me 0 over 0. I don't really care what happens at that place. Okay, so that's your hole in the graph, and it's said to be indeterminate. When you have 0 over 0, and these are nice functions, I'll call them polynomials, but I know you're not sure what those are, like x squared. That means it's going to factor and it's going to divide out, which is nice to know. Okay. Oh, yeah, sorry. Bring that up. Is that better? That? number 3 is undefined. It's going to be a vertical asymptote. And what you're going to get is positive or negative infinity. But we haven't gotten there yet. Right now, we're just trying to find the y values. So right now, you can't. Because when you divide by 0, if you have ever tried it on your calculator, you get a very, very big number or a very, very small number. If you divide by 0, you're going to get an error. Okay, are we ready? Now, this is another crucial point right here. You have to know this, and you have to be able to say it. Okay, you want to meet your parents down at Cub. You go to Cub, and your parents end up going to the old Kmart. Did you guys meet up? No, that's the problem. It's the same with limits. You have to follow the paths, and you have to meet up. So the limit has to approach the same value, the y-coordinate, from both sides. So if you're traveling down the road, and here's your little c value, if your parents are coming from this way, and you're coming from that way, you've got to meet at the same place. That's for a limit to exist. They ask you that on the exam, and you actually have to say the limit from the left has to equal the limit from the right. Now, you can write it just like I'm writing it. It doesn't have to be fancy. Okay? That's been on the exam at least the last 2 years, and because I'm a reader for the exam, I know it's going to be on there again, because I can already make predictions by what they've said. Because if students don't get that very well in the exam, they put it on the next year, and I believe they struggled a little bit with this one. So you have to limit from the left has to equal the limit from the right. You have to say that. That's what's going to be different for you, is writing those out. So how do we say it? And you could say it symbolically if you want. So how do you say it symbolically? I don't know if you can see that very well on the back, but I'm going to rewrite it. The limit, as x approaches the c value, and from the right, we're going to put a little plus sign in there. Just notation. If you want to come in from the left side, what do you think this is going to be? C negative. Now, the only problem, that's okay. If you kind of get mixed up, so make sure you read a couple times. Like they say when you build something, measure twice, cut once. In my case, measure 4 times, cut once, because I have a little bit of a problem with that. But if x is approaching negative 2 from the left, don't get the signs mixed up. This means left, and this means negative. So is it easy to misread these? Yes. So read it a couple times to make sure you're answering the question. And you'll have a quiz on this, and a quiz on the worksheets. It'll come up probably next week, I'm going to guess, and it should be on the calendar. And don't forget, I started, so I didn't finish it. On Monday, Thursday, Friday, and you can come in Tuesday, because Mr. Dahman's there on Tuesday, 1410. And honestly, I'm probably there every day anyway. Okay. Letter C on your handout. If you turn it over. Oh, you worked in the book? Oh, that's right. Oh, yeah. If you look at this in the book, but I typed it wrong on your handout. So if you look at C, this should be a 1. So you have to turn the page. That should be a 1. Sorry. So we're going to do this together, and then we're going to do the greatest integer function. And then we'll do some questions on the worksheet. Okay, you ready? Now you got to read this carefully. Huh. Still think I can erase that because I already did once. Ready? Now it says the limit from the left. Nope. Read it carefully. the limit as x approaches negative 1 from the right. Now, you are stuck on that path here. Now, your picture's not as nice as I tried to make it with a mouse on a computer. Much easier to draw it up here. So you're coming into negative 1, but you're going to follow this road, and you're coming in from the right. What is the y value getting close to? 1. Is this true or false? True. I problems like this. Go back and check yourself later. Do this problem again. Okay, I'm coming into 0 from the left. You're going to follow this path. From the left, it's what? It's 0, right? So it's true. Now, remember, limit can only have one value. So I don't have to think about C. If B is true, then C has to be false. And as we approach 0, the value of the function is 1, but the limit is not. Do we care about what happens at 0? No. Remember I said that there was a typo on there. It should read 1. I typed yours wrong. I don't know how that's happened, but I don't know. So this is false. Because otherwise B and C are the same. Now, on D, it says the limit as x approaches 0 from the left and the limit as x approaches 0 from the right. Do they have the same y values from both sides? Yeah. They're going to meet. So that's true. So on the exam, you can write it symbolically like this, or you could say the limit from the left equals the limit from the right. It's your preference. Okay? Does the limit exist then? There's a hole there. Is that okay? Yeah. If you look at your picture, is there a hole there? Oh. Well, there's supposed to be a hole there. You can see it on mine. Okay, but well, otherwise I wouldn't have a function. If there's no hole there and I have a dot at 1, I don't have a function, do I? Because it fails which test? Vertical line, good. Okay, so this is true. What is the value of the limit at 0 then? You really always have to check from both sides. This is clearly a nice function except for that hole. Is this true or false? F. What's the value of the limit? What are the y values getting close to if you travel down this road or this road? They're both 0, so that's true. How about the limit as x approaches 0, and they say the function's 1? No, f of x is 1, but not the limit, so this is false. And like I said, it can't have two different values, otherwise the limit doesn't exist. And what about as x approaches 1? And I wish the author did this a little bit better because they could have actually broken it down into pieces. What is the limit as x approaches 1 from the left side? So you're going to follow this path right here. It's what? 1. Good. What is the limit as x approaches 1 from the right side? I'll slide this up a little bit. Not that much. Now, I'm coming in from the right side. Do you have this little line here? Well, put a little line there if you don't. I'm coming in from the right side. What's this value? 0. So when they ask this question on H, you can't say the limit from the left equals the limit from the right, so this is false. Because then which one is it? Is it 1 or is it 0? You can only have one answer. What about the limit of f of x equals 0? Well, obviously that's false because the limit doesn't exist. And what about the limit as x approaches 2 from the left? So you're going to travel on this road. What's the y coordinate here? No, that's the x. What's the y? 0. Is that easy to make a mistake? Yes. This should be 0, shouldn't it? So this would be false. Yeah, it's hard to see the line. I probably should fix that. I should fix it before I forget. Better feel for limits now? How about you guys in the back? Better feel for limits? They're not so bad. Actually, just doing limits isn't bad at all. Where's the hard part on the worksheet? Not the calculus. That's the calculus, limits. It's the algebra. You'll hear that all year. This is your class in algebra. Okay, we are now going to do the greatest integer function. Have you guys done that before? This is just the plain old greatest. The greatest integer function. Oh, as the word integer. What's an integer? We know what greatest means. I know that. But what does integer mean? Not real numbers. 1/2 is not an integer. What kind of numbers do they have to be? Whole numbers. But I could have a -2. I want to get the, and that's rationals are fractions. Those are good guesses. But whole numbers and their opposites. Zero is its own opposite. So you're only talking about whole numbers. And you could have negative whole numbers. So what does this mean? I want the greatest integer that is less than or equal to whatever's in this little symbol here. Less than or equal to x. I want the biggest whole number that's either equal to whatever number's in there or smaller than that. This is a rounding down function. We have that on our cell phones. We have that on our calculators, on our parking, but it's rounding up functions. What if you talk for 1.5 minutes? What are they going to charge you for? 2. That's a step function. That's what this is. That's a least integer function. Goes the other way. Have you ever been a parking ramp? And you're there 5 minutes longer than the first hour. What happens? They charge you for 2 hours. Well, not me. I just smile at them. I say, oh, come on, it's only 5 minutes. And I usually get out of it. Depends on how nice the person is. I don't think that's fun. Okay. Okay, so let's graph this by hand. And we're going to make a table of values. And then I'm going to show you how to do it on your calculator. What is, let's start with 0. What is the biggest integer that's smaller than or equal to 0? Okay, so if I say it in my head at least, like I just did, then it's easier. So what if I have 0.1? I want the biggest whole number that's smaller or equal to that. 0. 0.9. I want the biggest integer smaller than this. 0. It's a rounding down. Goes to the integer less than that. What about 1? That's 1. What about 1.5? That's still 1. How about 1.8? 1. Look at these little horizontal lines. So we're going to graph it. So at 0, we get 0. And all these numbers between 0 and 1 stay at 0. And when I get to 1, what's it going to do? It's going to jump. And so now we're going to go over here. And at 2, what's it going to do? It's going to jump. Looks like a step function. It does look like steps. If you have an 83, you'll have to change the mode on your calculator to the dot for you to see it. Otherwise, it'll look like steps, literally. Okay. Now we'll do the hard part. What about the negatives? What if I have, and now be careful, just wait a second, let me say it. I have -1/2. I want the biggest integer smaller than that. -1. Is it easy to go the wrong way? Yes. What if I have -1? Biggest integer less than or equal to still says -1. -1.9 rounds down. -2. So we're going to get the rest of the steps. So if you're anywhere between 0 and -1, it's going to go to -1. Now the problem with the calculator is it doesn't show you the intervals, like this is open and that's closed. If you trace, you'll see it. But it's really hard to see because in reality, these circles, I'm drawing them big so you can see them, but they aren't any bigger than any other point on the line. Is this continuous function? I haven't really talked about continuity. Continuous means you wouldn't be lifting your pencil. So if I'm here, to get up to the next one, there's a break in there, right? Jump. So let's put this on our calculator. Some people in the last class knew where this was on our calculator. Okay, I don't like that one. Let's get rid of it. Y equals, we're going to clear that out. And the greatest integer is in the math menu. Yep, it's in numbers. The first one is absolute value. And you go down to 5. And there it is. Of x. And I don't have to close my parentheses. I should. And now we're going to zoom it. You guys like zoom 6. I don't particularly care for it. But there you can see the steps. Now, do we have any 83 users in here? You probably have. You have they're connected, aren't they? Yeah. Okay. So what you do here is you go under mode. And you go under, all the way it says connected, go to dot. It won't affect mine. I'm going to go to dot mode. And then press graph. And there it is. Yeah, you don't have the other option. Well, that one's okay. It will. If you leave it in dot form and you look at other graphs, it'll look weird. There'll be dots. But that's okay. Now, I don't like zoom standard. I like to zoom decimal, so I'm going to go to zoom decimal. And I like that one much better because I can see it. Plus, if I trace, I have nice numbers. Okay, there. Now you couldn't see that because it was on the axis, but now you can. So y value stays there until I get to 1, and then did you see it jump? Okay. Those of you with 84s, you can do what I'm going to do. Go over here to y equals. You guys in the back? And you may not have seen this. Well, I went to dot mode, so see it's all dots here now. 84s, you could do the same thing. But we're going to go over here, and we're going to change this. I'm going to press enter. There's my solid line, which is where you're starting from. And I'm going to press enter again. That makes a thick line. You can see the pictures here. And if I do that one, it's going to shade above. Yeah, that's kind of cool. If I do the next one, it's going to shade below. Can't do an 83, I don't think. Oh, you can. Okay. Okay, I'm thinking of 82. Sorry. Okay. And if you press enter, this is my favorite one. That's the circle trace. Let's watch this one. We're going to do that graph. You can actually see it jump. It puts the vertical lines back in. But isn't that cool? But you can still see it. Okay. Now, let's look at my picture here. What is the limit as x approaches 1 of my greatest integer function? What's the y value as x approaches 1? You're close. What do you have to do? Remember what you have to do. You have to check it from what? Both sides. So I'm going to have to take the limit. I'll slide this. As x approaches 1 from the right side, and I want to find out what the limit is as x approaches 1 from the left side. Okay, so if I'm at 1, I want to approach 1 on the x's from the right side. I have to follow this path. What's the answer here? 1. And if I come in from the left side, the y value is 0. Since the limit from the right does not equal the limit from the left, does not exist. And you would, on the exam, either say limit from the right or the limit from the left. You could even do this. Limit as x approaches 1, right does not equal the limit as x approaches 1 from the left. You have to be able to convince the reader. That's pretty convincible. Pretty clear. Although don't try to make up your own little notations. And we even talk about that. What will they accept and what won't they accept? As we're grading, somebody will write something weird and we'll say, what does that mean? You just better hope somebody's not too tired. Okay, there's my graph. We're not going to do this today. We're going to do this Monday, because that's a little bit tricky. Were there questions on your white worksheet? By the way, I'm going to tell you right now that number yeah, but 11 is that cubic. That's a cubed plus b cubed. Remember that? Is a plus b, a squared plus ab plus b squared. And number 14, we haven't learned how to factor those. I mean, I know how to do it. It takes a lot of time. We're going to graph. Do you have homework? Oh, yes. The yellow sheet that has the squares, what time is it? We got time. The yellow sheet with the squares is what we are doing for work. So you don't have to bring anything home but this. You know, the textbook's online, so you really don't even need your book. This is all we're assigning is this worksheet. You could always leave your textbooks in your locker, except you need to bring them to class. But to bring them home, if you don't mind working off the internet, no big deal. Yes, we have to do 11.
I know, but
That's absolute value.
right sheet.
This is greatest integer. Yeah, that's the same.
Well, I know, but you wrote 11 up there.
No, that's off the white one. Sorry. This is off the white worksheet, and I'll get the answers put up there, but mostly things looked really good when I checked around the room. Number 11, you just have to factor it like that. We'll do it Monday. But let's look at number 11 on the yellow one. Now, I hope you can do number 1 on here. Number 2 is the greatest integer. Use your graphing calculator to help you with that, because you're not that familiar with the greatest integer. And it tells you which one should be done algebraically. On the back side, the ones that have the trig, use your graphing calculator. We did 14, so it's done. Try 15 and 16. Don't be scared of those. Just do what it says. I think now we did one with a square root in it, so number 8's like the one we had with the square root. The only one I think you should really have difficulty with is 5. But we're and 11. So let's look at 11. My bet is that you don't have any idea what that looks like. No. Okay, so what we're going to do, pretend that it's a new TV show, Revolution, where all the power goes out. Now you got to do this problem. Actually, I'm one who's in trouble because I can do this, and what value is that going to be? Not much. Okay, so I'm going to break this down because the absolute value is a piecewise function. And I'm not going to give you the definition yet. We're going to kind of figure it out. So I'm going to draw the absolute value function. And we all know what that looks like, right? What's it look like? Looks like a V. I know you guys are not going to want to do this algebraically. So this is a piecewise function. Okay, guys in the back? This is another thing I guarantee that you're going to see on the exam, because students do not do well with piecewise functions. So they said at the reading, we continue to expect to see piecewise functions. You cannot describe real-world events with one single function, except maybe the seasons with a sine curve. That's about the only thing I can think of. So you have to have pieces. Well, this function occurs so often that somebody made up this symbol. They said, I don't want to write these other pieces out every single time. It's so common, we're going to write it like that. I don't know who it was that did it, but somebody did. So how would you write the equation of this line? Y equals what? X. Provided that X is a positive number. You should have seen this before, but you may not remember it. And what about this side? Minus X, opposite of X, if X is a negative number. And that's the definition of an absolute value. Now, if I just look at that with the symbols, it's kind of scary. If I look at it with the graph, it makes total sense. So somebody didn't want to write all this stuff out every single time, and so they made up a symbol. There are other piecewise functions you could create. You could make up your own symbol if you found that it occurred often enough. But it probably doesn't. So now let's look at this limit. We have to look at this from the right and from the left. And actually, we can see what it might look like if we're careful with it. So I'm going to write that out. I want the limit. Let's start from the right first. As x approaches 0, because that's easier, of the x over the absolute value of x. Well, x stays as x, but what if x is coming in from the right? I don't have to write it in absolute value. What's the equation of that line? It's just what? Remember, x is a positive number. Do I need the absolute value symbol? No, it's just x. So what's that value? 1. You can put numbers in, you'll see that. What if I take the limit as x approaches 0 from the left? Well, the x is still x. That's line y equals x. That didn't change anything. But now, if I'm coming in from the left on the absolute value, and I don't want to write it with the absolute value symbol, negative of x. Excellent. So what's that equal to? Negative 1. What's the limit as x approaches 0? It's 1 from the right, negative 1 from the left. Doesn't exist. What does this graph look like so you kind of believe this? Kind of an interesting function. It actually has something to do with a derivative. Wait, let's just graph it. It's this one here on the right, and it's this one down here on the left. Doesn't come into the same place. You're not going to meet mom and dad, are you? Okay, have a great weekend. See you Monday morning if you're having problems with anything. Okay? Yes, this is already online. This one is. Only the white one, because that was new this year. And the other one will